Excuse me, this is number 9, Tyler. A new apartment complex advertises that it will give away 3 mopeds by a drawing from the first 50 students that sign a lease. 4 of these students are among the first 50 to sign. What is the probability that at least one will win a moped? Sorry, I had to make some room on my screen here. So we've got 4 of the 50 that are the friends, and so the probability that one will have a moped, will win the moped, well, one of the friends, has a chance of winning 4 out of 50. Okay? Now, that means then, if it's exactly one of the friends that wins the moped, then that means the remaining 3 are not friends. So there are 46 people in the group that are not a part of this group of 4 friends, but we've picked one person, and therefore there aren't 50 people remaining, but only 49. So the probability that the second person selected wins a moped, is not a friend that wins a moped, would be 46 out of 49. The third person, not being one of the friends that wins the moped, there are 45 of them left out of a total of 48 people in the group. And the fourth person, there are now only 44 non-friends left out of a total of 47 people who are left in the group. So to find the probability that the first person is a friend, the second person is not a friend, the third person is not a friend, and the fourth person is not a friend, is equal to the product of those 4 probabilities. I'm going to change that to a decimal. So I multiplied all my numerators, multiplied all my denominators, and divided numerator product by denominator product, and got about 0.066. Now keep in mind, Tyler, though, this is the probability of this particular combination of one friend with 3 non-friends. This is a rather complicated probability question. You've got to remember that there are other ways for one friend to get the moped and not the other 3 to be a friend, if that came out correctly. The friend could be the second person, the friend could be the third person, or the friend could be the fourth person. So basically you have to factor in the number of combinations of one friend with 3 non-friends. And there are 4 ways for that to occur, and therefore the probability that exactly one friend gets the moped would be 0.066 times 4, which is, I've left my answer exact on the screen, but we'll round it here, 0.264-ish. Well, now we have to factor in, okay, what about the probability that 2 of the 4 are friends? Because it said at least 1. Well, at least 1 would be 1 or 2 or 3 or 4 of the friends get the moped. Well, if you think about that, Tyler, the only possibility that's not in this is if 0 friends get the moped. So there's an easier way to go about doing this. 0 friends getting the moped is the complement of what we actually want, which is 1 or more friends getting the moped. So if we can find the probability that none of the friends get the moped, we can subtract it from 1 to get the probability that 1 or more get the moped. Well, this is pretty simple. The probability that 0 of the friends get a moped would be, okay, there's 46 non-friends in the group out of 50 people. I don't put that non-friend back in the group, so now there's 45 people that are not friends out of a total of 49 people remaining. For the third person, now there's 44 non-friends out of a total of 48 people left in the group. And for the fourth person, there's now 43 non-friends out of a total of 47 left in the group. We can find the probability that none of them are friends by multiplying those together. And that equals about 0.709. So since we want the complement of that, we're going to take 1 minus that answer. And we find that the probability that at least one of the 4 selected is a friend is about 0.291.